Welcome again to another video about differential equation. Now we are going to see the type of linear differential equation. Uh, as you know that we have seen separable differential equation and exact differential equation, homogeneous differential equation. Now we will still have three or more than three types to see in the first order differential equation. So let's get started with linear differential equation. When we say that the differential equation is said to be linear if it can be written in the form of y prime plus px y is going to be equal to qx. So as you can see here, if a differential equation is written in this form, so it's said to be linear. We have just a remark to tell you about. You can notice that the coefficient of y prime is going to be 1. We need only to make it 1 if it's not. And the second remark that you can see, which is px and qx, are two functions with respect to x. So if it's containing y or something, so it's not a linear differential equation. So what should we do right now is to give a general solution for this kind of differential equation. Then we are going to see some examples and solving them. So let's see the general solution of this differential equation. And the first thing that we need to do is to calculate a quantity, which is u. Let's call it u. It's going to be equal to the exponential of the integral of px dx. When we calculate this quantity first, we need to multiply it in our equation. Let's call it star. We multiply star by exponential integral of px dx, which is u. Then we will obtain something, which is it's going to be exponential. Sorry, let me write in black. It's going to be exponential of the integral of px dx times y prime plus px exponential integral px dx times y is going to be equal to qx times exponential of px. Yes. Now we have obtained something. So this is going to be u times y prime plus something times y equal to qx times u. And let's calculate u prime to see something, which is u prime is going to be the derivative of exponential of the integral of px dx is going to be px times exponential integral of px dx. And as you can see, which is also px times u. As you can see here, this quantity is already here. So this is going to be u prime. If you notice something, that we have u times y prime plus u prime times y. And this is the derivative of the product of the function, which is u times y. All prime is going to be u prime y plus y prime u, as we have seen. So it's going to be the derivative of the product of two functions is going to be equal to qx times u. So We need to obtain y since it is the solution of our equation. So by integrating both sides, we are going to get u times y is going to be equal to the integral of qx times u. As you can see, when we integrate this quantity, we are obtaining a c as a constant. So I'm going to add a c right here. To obtain y, so we need just to divide by u. So y is going to be 1 over u times integral of qx, sorry, here going to be dx times u dx plus c. As you can see, this is a general. Let me rewrite u as exponential of minus the integral of px dx times integral of qxu dx plus c. As you can see right here, this is a general solution for a linear differential equation. It's not the only method that we have, but I think this is the easiest method that we can use to solve a linear differential equation. Now, to make sure that you have understand, let's see some examples about, yes. The first question said determine whether the following differential equation is linear. Let's see the first example. We have y prime plus exponential y is going to be equal to x squared y squared. As you can see here, the coefficient is 1, so this is the first step. And we have something times y, which is, let's call it px, and here we have the problem since it is qxy, which is a function with double variable or multiple variable x and y. So it's impossible to make it only as one y, so it's not a linear differential equation. And the second example set, we have y plus sine x is equal to x to the power of 3 y prime. As you can see here, the coefficient of y prime is x to the power of 3, so we need to make it as 1. So we need to divide by x to the power of 3, and we are obtaining 1 over x to the power of 3y plus sine x over x to the power of 3 is going to be y prime. So what we have y prime minus 1 over x to the power of 3y is going to be equal to sine x over x to the power of 3. As you can see here, we have the coefficient of y prime is 1, and we have this is as px, a function with respect to x only, and this is a qx, a function with respect to x only. So in this example, this is a linear differential equation. Let's see the last example in this kind of question. We have x, we have x y prime plus ln x minus x squared y is going to be equal to 0. The first step that you need to do is to make the coefficient of y prime as 1. It's going to be divided, we are going to divide all the equation by x. It's going to be y prime plus ln x over x minus xy. It's going to be equal to 0, and it's going to be minus y prime minus xy is going to be equal to minus ln x over x. As you can see here, we have a y by itself, we have a px right here, which is going to be equal to minus x, and qx is going to be equal to minus ln x over x. And this kind of question is just to remember the form of a linear differential equation. And let's see, so let's solve some differential equation which is the most popular problem they are gonna face. Let's get started with the first one. Yes, the first one said solve the differential equation. Of course, we have y prime plus 2y is going to be equal to exponential x. As you can see here, the coefficient of y prime is 1. We have px, which is equal to 2, and qx is equal to 2 times exponential x. So what should we do is to calculate the quantity, calculate mu, or let's call it u, which is going to be equal to integral, the exponential of the integral of 2 dx is going to be equal exponential 2x. This is the first step that you need to do. The second step is multiply, let's call it star, multiply star by exponential 2x. Or if you want a yes, multiply it by exponential 2x. So we're going to obtain exponential 2x y prime plus 2 exponential 2x y is going to be exponential 3x, since x plus 2x is going to be 3x. So in this side, we are obtaining exponential 2x times y all prime is going to be equal 2 times exponential 3x. So by integrating both sides, we're going to get exponential 2xy is going to be equal to the integral of 2 exponential 3x. And this is an easy, yes, the integration of 2 times the exponential of 3x is going to be 2 over 3 exponential it's going to be 3x plus c. So we need to multiply by exponential to the minus 2x. It's going to be y is equal 2 over 3 exponential x plus c exponential minus 2x. And this is a general solution to our problem. Let's see another example. This is example number 1. Let's see example number 2. In this time we have this equation, which is x y prime minus 2y is going to be equal to x squared. The first step that you need to do is to make the coefficient of y prime, as already said, as 1, which is we need to divide by x. Minus 2 over x is equal to x. Since we divide by x, it's going to be here, it's going to be x over x is going to be 1, minus 2 over x, and x squared over x is going to be x. So the second step is to calculate u. It's going to be exponential of minus 2 over x dx, and it's going to be exponential of minus 2 ln x, and it's going to be 1 over x squared by using the laws of ln. It's going to be ln x to the power of minus 2, which is 1 over x squared. So we need to multiply our equation, this equation, by 1 over x squared. Let's see what we are going to obtain. We're going to obtain 1 over x squared y prime minus 2 over x to the power of 3 y, y is going to be equal to 1 over x. So right here we have the derivative of the product of two functions. It's going to be 1 over x squared times y. It's going to be equal 1 over x. By integrating both sides, we're going to get 1 over x squared y is going to be ln x plus c. Multiplying by x squared is going to be y. X is equal x squared ln x plus c x squared, and this is a general solution to our problem. Let's see another example. I think that now everything is clear. If you haven't understand something, you can leave it in the comments so I can explain more and more. So let's see another example which said x y prime plus y is going to be equal to square root of x. As you can see, this we need to divide by x. Is going to be y prime plus 1 over x y is equal to the square root of x over x, which is going to be 1 over the square root of x. Okay, so we need to calculate mu. It's going to be exponential of the integral of 1 over x dx, which is going to be exponential ln x, and this is going to be equal to x. So we need to multiply our equation by x. When we multiply this equation by x, we're going to obtain this equation. Since it's it's something difficult to see that this is the product of two functions. So it's gonna be this x y all prime is gonna be equal to the square root of x. By integrating both sides, it's gonna be xy right here is going to be equal to the integral of square root of x dx. So it's going to be xy is equal to the square root. The integral of the square root is by adding 1 to the power. It's going to be x to the power of 1 over 2 plus 1, which is 3 over 2, and we need to multiply by the inverse, which is 2 over 3 x to the power of 3 over 2 plus c. So now we need to divide by x. We are going to get y is equal to over 3 x to the power of 3 over 2, and it's going to be over x, it's going to be the square root of x, and plus c over x. And this is a general solution to our problem. Now let's see the last example. I think that you have got the idea how to solve a differential equation this form. Let's see another example which said, yes, let's see this example. Let me see another one. We haven't dealt with that. Let me just see if we didn't do that so we can deal with it right now. Yes, which is gonna be y prime is gonna be equal x plus 5y. Y prime is gonna be equal to x plus 5y. And it's gonna be y prime minus 5y is gonna be equal to x. So mu is gonna be equal exponential of integral of minus 5 dx. When we integrate it, we're going to be minus 5x. Here dx is going to be exponential of minus 5x. When we multiply this equation by mu, we are going to obtain exponential minus 5x y prime minus 5 exponential minus 5xy is going to be equal to x exponential minus 5x. So right here in this part, it is the derivative of the product of two functions, which is exponential minus 5x times y, all prime going to be equal to x exponential minus 5x. So by integrating both sides, we're going to get exponential minus 5xy is going to be equal to something. We need to get the integration of the thing x times exponential minus 5x. We are dealing with it by integration per parts, so we are obtaining, let's do it right now. It's going to be x exponential minus 5x. When we get the derivative of x is going to be 1, the derivative of 1 is going to be 0, so we should stop here. And the integration of exponential minus 5x is going to be minus 1 over 5 exponential minus 5x. I think it's easy, you can deal with it by yourself. And the integration of that is going to be 1 over 25 exponential minus 5x. So here we have plus and here we have minus. It's gonna be x minus 1. It's gonna be x times minus 1 over 5x minus 5 minus 1 over 5 exponential minus 5x, which is minus 1 over 5x exponential minus 5x minus 1 over 25 minus 1 over 25 exponential minus 5x plus c. Now to obtain y by itself, so we need to multiply the equation by exponential 5x. So it's going to be y minus 1 over 5x, yes, minus 1 over 25, yes, and plus c times exponential of 5x. So this is a general solution for the differential equation that we have seen. And let's see a simple example, maybe another example. I will leave for you an example to deal with it, and it is easy also, and which is, it said like what we have y prime is going to be equal x sine 2x plus y tangent x, and I will give you a hint. So sine of 2x is going to be equal to 2 sine x cosine x. And this is the end of the video. Thank you for watching, and I hope that you have got the idea how to solve the linear differential equation. See you in another video with another type of differential equation.